That should do. So, hello everybody. So yeah, welcome to the InSpec release party. We're here at Endocode. Maybe some of you already been here. Endocode is a software engineering company from Berlin. And yeah, we're happy to have you guys here. And I'll hand over to Christoph, who's going to have the first talk.
Thanks. So I'm so happy to be here. It's our InSpec 1.0 launch. We launched yesterday, and today is really the first presentation we're going to do. So I'm really excited to have you all here, and I'm going to talk a little bit about InSpec, what InSpec is, and why you should use InSpec. A little bit about myself. I'm Christoph Hartmann. I'm engineering lead at Chef for compliance. So all topics talking about compliance is covered by our team. So just start about what InSpec is, right? InSpec is a tool for turning infrastructure testing, compliance, or security testing into code. So you say, hey, what is that? And it's really started in April 2015. So Dominic Richter and myself started a new project, a company called VolcanoStack, with an initial commit of our tooling. And that was the first start where we tried to achieve one goal. And that was, how can we ensure compliance in combination with DevOps tools? So assume you use Chef, Puppet, Ansible, you roll out everything automatically. But if you want to have the security tools, it was so hard to combine them together. So that was the initial start, how to bring that together to have the safety with the automation that we have. So we started there. So in November, Chef announced it as an open source tool. Before it was only closed source. Chef acquired our company and decided to open source InSpec. So InSpec as a foundation is built into Chef Compliance as well. Chef Compliance and Chef Automate now is our commercial offering. So it's shipped since last November in our commercial product. So it evolved over time. So even though we are saying it's InSpec 1.0, it has been used in production now since nearly a year. So that is really exciting. So to have that on top. So we had 86 releases. We had nearly 60 contributors. So that's amazing. And about 3,000 commits. So that's pretty awesome. And also we have major commits from HP and IBM to support AIX, for example, or HPUX. So all those has been contributed by those companies because they are using it for ensuring their safety. So we talked a little bit about InSpec, how it came to be, and the interesting question is, why should I care about that? So assume you have a car, right? So you're saying, hey, you know it works. Why should I care? Everything is all right already. But now you have the cool DevOps tools. So hey, let's build a new engine. That's cool, right? So we are now faster. We ship faster. Everything is better. But are you really sure that this is what you want? Of course you want to be faster. But at the same point in time, when you're shipping software faster, you need to ensure that everything is secure as well. So assume a car, like this is not safe on the street. So try to get that approved. Yeah. So I doubt you will get it through. So that is something that you need to consider once you run a production application. So just shipping fast is not the solution. You want to also ensure that you ship with safety. You don't want to break production software. So once you release more often, you cannot check that manually anymore. It's just not working out because those testers are always the blocker then in your team, because once you ship and you ship and you ship, the team is testing, and that's doing manually, it's not working out. So think about that. We have a really short deploy cycle, but we need safety, and we need to also ensure corporate guidelines. If you work in a bigger environment, normally you have a couple of requirements that you need to follow once you ship software. So how do you ensure that all your deployments you're doing are really compliant to that environment? So that's challenging. So what do you really want, right? Is a real car. So that is safe, looks good. So everything as a combined package. And we say InSpec is the right tool to combine with the DevOps tools to make that happen. So to have a real good package around that. So just deep diving into a little bit what InSpec is InSpec is really a command line tool. A command line tool where you have commands available, and you can play later with that. And the simplest example that I can give you is verify that the SSH configuration is properly done. So what you just create a short script and say InSpec executed, and we see it in a second live. But this is roughly how it works, right? You have a test and you run it. Pretty straightforward. So if we combine that with Chef, so Chef is a tool for rolling out DevOps, and InSpec is really the testing side of it. It just verifies that everything works. So it has really similarities, but I want to highlight one major exception, that is how we execute it. So InSpec can be executed locally, remotely. It can use SSH, Winner, and Docker. So that means you can have your test locally and just test everything. And we have companies testing it from AIX servers to Docker containers with the same framework. So that's amazing. Try to do that with another framework. If you're talking about compliance, you need some more information around those tests, right? And that is a title, a description, an impact, and that enables you to share that across the teams. So now even if you have people on the team who are not able to fully understand what's going on here, technically they can read the description, they can follow it, and they can understand it. So that is a major improvement that we have added. So again, this is how we can execute the same task via SSH. So run it on a remote machine. We run it on a Winner, and Microsoft just announced yesterday that they have Windows 2016 available and Windows Nano. So we ship with InSpec 1.0 also Windows 2016 and Windows Nano support. And we will see it in action in a second. So you can trust me that it works. Docker, of course, is also supported. So the cool thing about Docker is you don't need SSH installed or like a lot of other tools required to connect to it. It's using the native Docker API to connect to it. So you can have plain containers as you build them right now, and you can verify against those. So that's really cool because no additional software is required. And once you go container, you really want to go that approach. Another core feature of InSpec 1.0, and that is really like required by bigger organizations, but it's really handy for everybody else as well. As they have, think of it, they have corporate guidelines they need to follow. So as, for example, if you have credit data processing, you need to follow the PCI DSS requirements. And they roll down to CIS requirements, so a lot of things are in between. But you will have, at the end, you will have a profile that says, hey, this is my CIS profile for Windows, for Linux, for Tomcat. So all those are available from the Center of Internet Security. And we, as Chef, we ship those with our commercial products. But once you have those, you will figure out, I have maybe a legacy application that cannot comply with those rulings. So you need to adapt that, right? So you cannot fulfill it, and you will not say, hey, everything is false all the time. So you don't want to have the false positives. So instead of copying it over and changing the profile, we say we do an overlay on top. An overlay allows you to customize a basic set of rules. Say I deviate with some rules, and that's pretty straightforward. In your profile, you just say, include the base profile, I skip some roles because they don't apply to my environment. And then I can also change the credibility of another control. And on top, of course, you can add more controls as well. So that gives you full power about tests that you have and for deployment across your infrastructure. And that makes it really manageable. So you can derive then from there, you can say, if I want to have something for development, for production, for testing. So that's now pretty easy. So whenever we as Chef, for example, ship a new update or a new version of the CIS profile, your deviation profits automatically because fixes that have been applied are automatically propagated to your profiles as well. So less managed on your side, more management on our side. Of course, those profiles allow customizations. And you can, in this case, for example, what we're doing is we check for SSL, right? That's a custom resource. Now it's integrated in InSpec, but you can write this as a custom resource, and that's pretty straightforward. So you add something to the profile, it's all Ruby, you can define it, and then you can have everything optimized for your application that may not be open source. So that means InSpec ships with a lot of default profiles that are available, but if you have something custom that is not available publicly, you can customize it to that. InSpec comes with a nice feature. It has InSpec init profile, so that creates an empty profile. So to just start and to have everything that is required, but it's really straightforward. It creates an InSpec YAML, it's the metadata, and then the controls directory, and then you need just a simple test file. So pretty straightforward. The cool thing about InSpec is it's really, really independent of the DevOps tools. So while it works perfectly with Chef, it also works perfectly on environments where you have Puppet, Ansible, Salt, or manual deployments. So that makes it pretty easy to migrate from, okay, I've manually deployed it, I already verify infrastructure tests against those servers, migrate to automation. And that also is helping you to define acceptance criteria for doing the automation. You can say, hey, this is my server, this is still manually deployed, I write my tests first, verify what should be there, and then I have an acceptance criteria, and I can move to automation and verify that all the time. So let's have a look at a demo. So what we are going to see now is we have one implementation for SSH hardening, and that's Chef SSH hardening. It's available in our DevSec IO project. So in case you don't know that, that's our security and hardening project that cares a lot about automation. And we will see here that this is just a normal cookbook. We run an external InSpec profile. So it's completely independent from the cookbook. It's integrated in Test Kitchen, another tool for doing testing. But the same applies for Ansible. And we use here Kitchen as well. And we run the same profile. So that ensures we have really the separation of concerns between DevOps tools and testing. So especially if you're working in a bigger environment and you may not have one tool that can rule everything, and you have teams deciding for different toolings, at least from compliance and security perspective, you can define one profile and share them with all teams so that they can use them everywhere. So just to show how that works, this code is available on devsec.io, but let's just run it quickly. So in this case, we run Kitchen with Ansible. I just pre-deployed it so that it's a little bit faster. So it downloaded the profile from GitHub, and it's running then all tests. So it looks good for Ansible. Let's take a look if it's working for Chef as well. I assume so. It's downloading, and it runs perfectly. So that shows that no matter which DevOps tools you're using, it's possible. And it's straightforward to implement. those tests. So here you have an InSpec YAML. So that is giving you some basic information about its name, title, maintainer, the license, the summary, and I'd like to highlight the supports flag. So the profile knows if it can run on that operating system. So that we will see in a second why that is important. Remember that. So for example, for SSH, it's not available on Windows, so this profile knows it cannot execute on Windows. So InSpec will skip all those controls. For SSHD, so we take a look. This is how we define it. So we have, for example, an only if command to say this whole profile cannot execute it if SSHD is not installed, right? So it doesn't make sense to have red flags all the time if SSH is not installed. If you run that on a Docker container, if SSH is not installed, you cannot false configure it. There cannot be a false configuration. So that is something that we want to prevent here. So this helps you to manage that. On top, we have a couple of resources, about 60 default resources that ship with InSpec, so that it gives you abstraction on top of everything that runs on the operating system: users, groups, SSH, registry keys, security policies. So a lot of things are built in, and you can just leverage that and define on top. So this is a profile. It's just a collection of tests and description. So that is, once you have to do it multiple times, and historically that has been done in PDF documents where they said you have to ensure A or you have to ensure B, and now you can automate that, and that helps you to really run that everywhere. So you write it once, you do the optimization for every operating system in InSpec, and then the developers who have to comply to those can really focus on implementing the automation. Cool. So this is covering the infrastructure testing. So in this case, you see we used the same profile for different DevOps tools. Of course, you can just bind them into like a Chef cookbook and put them the test integration directory works as well. So you don't need a separate profile in case it's just a simple infrastructure test. And I would prefer to do that if you're just doing cookbook tests, because it helps you to keep everything together. In case you need it, spread it out, it's possible as well. So the next example that we are showing is about patching. So patching is an interesting topic, and especially if you have to do that across multiple operating systems. So is that an easy task? So my perspective, it's not. So you have multiple operating systems, multiple patch levels. So you need to ensure it for Linux and Windows. And I will show you in a second how you can easily run that, no matter which operating system is running, and you see if patches have been applied. Right? Try to do that. So we have Windows Patch Benchmark available here, and you may have seen this message for Windows. You need to install everything. And InSpec is reflecting that same in code, so that allows you really build on top of that. You can derive profiles. So all the mechanisms I just showed you to derive profiles you can use with that as well. So it gives you now a lot of like coding experience on top of what we've built. So let's just run that. So I have, here's a Windows Nano running. And I have here. So we have here Windows Nano, and I'm going to run the Windows Patch Benchmark on Windows Nano. So that is now, InSpec is running locally on my machine. It's using WinRM to connect to Windows Nano, and then verifies that all patches. So in this case, Windows now has 3 patches available that need to be installed pretty soon. So of course you can make it more complex. You can say all patches need to be installed at a specific date, so everything can be programmed in InSpec. And you can say, hey, don't warn me if it's like 2 weeks or whatever is required. You can build on top of that. So the interesting part comes now. Let's try to say, I try to run the Linux patch benchmark against Windows. So, okay, so InSpec understands, hey, we added the supports flag. It's not running on Windows, obviously. So that is fun because I know that. But now I want to have my corporate environment covered with only one profile. I don't really want to decide if it's Linux or Windows. So now I have 100 servers, and I don't really care which operating system is running on. So what I've built is a patch benchmark that is a cross-platform patch benchmark, and it's depending on those 2 profiles. So I give it a depends, and that can be, the dependency can be stored on GitHub, in Git, in Supermarket. So wherever you have it, you can even store it on a plain web server and reference a tar file. So you can use pretty much everything you have and just put it there, and then have a dependency. And that can be used in here. I just say run all controls from Windows and Linux. And now you have seen a second ago that InSpec cannot run Linux profile on Windows. So let's try to run that. And we just have that patch benchmark. So we have our Meetup profile that is composed of those 2 profiles. And you see that the Windows patches have been scanned, and then the Linux stuff was not able to execute it. It's properly skipped. So it's not a red flag. It cannot execute because we said in that profile it only runs on Linux. So you see it's part of the Meetup profile, but not executed at all. So that's now making it pretty straightforward. Now try to run the same against Docker container. And I have fresh container here. So that takes a second. And here we see that we have now all packages with specific versions that we need to update. So that is now giving us a holistic view around our infrastructure for patching. And of course, this is only one example. You can do that with every application, and you can use the same mechanisms as we have done. Those profiles are available on DevSec GitHub, and you can just leverage them and use them with InSpec. So it's pretty straightforward. Go ahead, try it, give us feedback. So I'm really excited to see that in our space. So now we have seen the open source part of InSpec, and the funny thing is, how do you want to scale? We have the language covered, we have the automation covered, so we know how to run it from the local machine. We still want to run it on our whole infrastructure, and we want to work with more than one department. So we really want to have that in the pipeline. So that is really the goal of InSpec, to bring testing and security as part of the DevOps pipeline. So that's cool. But beforehand, as we talked about it, different tooling for testing don't allow you to make that fast. So with Chef Automate and Chef Compliance, we ship default profiles. So that makes it pretty straightforward to use. And we also have our commercial product. We have something that allows you to see Chef Converges and compliance in one interface. So that makes it really easy to see what's going on with my automation, but also see what's going on with my compliance status. And that helps you to manage it across your whole fleet. So now that we have the automation with InSpec and the engine available, it's really easy to scale that and scan not only yearly, but daily. So if something goes wrong in your infrastructure, you immediately get a notification. You immediately see what's going on. You can immediately react on what's happening. So that gives you a lot of good reliability on your infrastructure, because when something fails, you will know it. And that helps you a lot. So we as Chef, we really believe that the whole workflow is really the key to be successful, because there are studies out there that's found out that a company is doing a lot better when they are able to ship faster. So it's not they ship better products in the very first beginning, but once you are able to iterate faster, you can eliminate errors earlier. So the whole thing scales. So it's really easy to follow up on that. So of course, since now we have a testing language, we can bring in more departments in our DevOps workflow, and that allows you to really cover the whole infrastructure, because in the end, all those departments want to work together, and they may not have the same goal, but they can now describe it as one goal. And now if something goes wrong, they can specifically say, this went wrong, and they can talk about that specific issue. So InSpec is really bringing continuous testing and continuous compliance. So that's what InSpec is about. So thank you for listening to that talk. So I'm handing over to Patrick, who is talking a lot about how InSpec is used in companies.
Okay. So thanks for being here. Thanks, Chris, for your nice talk. I want to present you how to use InSpec for infrastructure testing and for security. Some words about me. I'm Patrick Münch. I'm working as an IT security consultant at SVA, and we're responsible for penetration testing, web application firewalls, DDoS protection, security audits, and so on. Thanks for this little talk about DevSec. I'm one of the co-founder of DevSec.io, and I just want to present you the test-driven development approach within this project. So you mentioned it already, Chris, thanks. Yeah, the Auditing framework provides you Chef cookbooks or Ansible playbooks or Puppet manifests to secure your infrastructure, your servers. And Auditing means that's a process of securing a system. So you want to roll out secure configurations for SSH or operating systems. So you have a secure default configuration, reduce your attack surface because you limit the service they are listening on interfaces, automatic deployment with Chef and so on, works on bare metal, cloud, and also for Docker containers. In this project, at first we are writing the test, what we want to implement with Chef, Puppet, or Ansible, and so on. So Chris also got a little overview of the test that you have, the impact, the title, description, and also the test. Right here we are testing for the permit root login in the SSH. So it should be no or without password, so that you cannot log in with a password to the SSH server. And then we are implementing the here it's implementation in Chef, so we implement this in Chef and so on, or other guys do it in Puppet. That's one where you have to use InSpec for sure. The other one is right now I'm working for a polymer company, and I have a proof of concept there. We are building a whole Docker data center with the universal control plane. Though they have a self-managed IT, nothing is outsourced in this company, so they build by themselves. And we have also some compliance, some requirements from the Federal Office for Information, that's German office in Germany, also for payment credit card industry requirements. And also they have a own security department where they define security rules, security guidelines. So right now we started to build the whole Docker data center, and we are using, for the first phase, we are using just InSpec to inspect the host operating system, because they are deployed not in a VMware environment, they also deployed only on bare metal. So you have a layer that means you have the host OS, then you have the Docker engine, and then you have the application. And we scan it, we roll it out with DevSec.io and other cookbooks, the host operating system, the Docker engine, and the applications. So then you use InSpec or Chef Compliance in the second phase to show the compliance of a server. And with such an architecture, you have something like this, like a small host-based intrusion detection system. Just imagine that the hacker hacks the Docker container or the host OS, then he manipulates at first the configuration to place a Trojan or to manipulate the syslog. If you monitor this with InSpec, then you can see the changes. Because if you use the InSpec in a cron job or something like this to scan it every day, second, minute, or week, what you want, then you can detect a shift of your configuration. And that's really a security, a real good stuff for security to detect such stuff. Because before you have to install tripwire or complicated programs and so on, that's not what you want as a security, because you want it small, efficient, not so much software. That's the second use case. The third use case, I use InSpec for my security audits. So imagine that a company wants to have a security check within this company, if they are secure or compliant to certain requirements and so on. Then we as SVA offer some packages, physical, operational, organizational, and technical security. And within the part of the technical security, right now we offer also the system security checks. So that means we are going on the system via SSH, WinRM, or what you want with the InSpec profiles to scan the whole system if they are compliant to the BSA, the federal BSA, we call it Germany, or the payment credit card industry standard, to have a compliance check, a report. And if I do that at the customer side, they're really impressed how fast they can get that. Because before they ordered a contract with a person, they need around about 3 or 4 days to examine all the compliance stuff and to check that. And right now I go with my laptop to the environment, get the SSH credentials and scan it in 1 or 2 seconds. And they are really impressed about that. And then I show the whole ecosystem with Chef Compliance, and they, oh yeah, cool, I want to have that. You can ensure everything. For my InSpec tests, I use for sure the DevSec.io tests and also some customized non-public InSpec tests that I have on my laptop. And yeah, that's it. And it's pretty easy. It's pretty, you write the test in a minute or 2. It's really, really easy. And thanks for this great tool, because that makes life easier. Yeah, that's it. And if you have questions, then just go ahead.
Yes? Question is, how deep can you inspect a container? For example, can you look into the files? Can you look into the memory? Can you look into the connections? I have a typical example of firing up VPS the end from inside a container, and it's nearly indetectable from the outside because it's in a different network namespace. And detecting things in different namespaces would be a big win for security. So, is it on a file base or is it on a memory base or?
Right now, I do it on the file base.
Okay.
But if you with the InSpec, you go directly in the container and check that stuff. So that should be possible to also inspect the net stuff, something like this,
Okay.
to inspect the open connections.
Yeah, for Docker, for example, we use both approaches. Sometimes you want to have really inspect the host, and sometimes you want to be in the container. So InSpec supports both approaches.
Okay.
All right, then, yeah.
You show the whole compliance from Chef, and does it have any API for checking result, like monitoring instead of doing like Chrome? If I have one place which gather whole statistic, I can build some alarms based on compliance from Chef.
Right. So the question was, has Chef Compliance an API to automate that? And yes, it has. It has a public documented API in Chef Web Docs. You can trigger, scan, you can get the report. So it's a complete REST API based on JSON. So whatever is available in our UI is available via the API as well. So the UI is only leveraging the API. So if you see something that is available, you can get that.
By triggering a scan, you mean, can you describe how people use that in the pipeline brain other than hooking that to some, like, in the pipeline? But I mean, it was mentioned that you can run it from Chrome or you can trigger the scan.
Right.
Okay,
so interesting question. The question is how I can run an InSpec profile. So which modes do we have available? So one mode is for sure the remote. So Chef Compliance, for example, is doing a remote scan. So you give it the SSH credentials, for example, and then it logs into and executes a profile. The other way that is available is the agent mode. So you can run it as part of a Chef client, for example, and then reporting to Chef Compliance or Chef Auditing. So that gives you a whole lot of flexibility how you execute the profile, because sometimes in air-gapped environments, you have not the ability to just SSH in. It's just not possible. So both approaches are valid approaches, and we support them both. So we have agent mode and remote mode, so that both are supported. Is that answering your question?
Yeah, I wasn't aware of the agent mode. And you said that agent mode is...
So InSpec is available as a package. You can download it and install it on every node, so that is available. You can just play with that and then execute it. It's just a Unix command. You can run it.
So that will be similar to how Chef is.
It's similar to how Chef is, with the exception that InSpec also supports remote. Cool.
Just looking for the configuration, like to inherit the SSH configuration from, I don't know, my SSH config file, or I need to pass all arguments if I have, I don't know, some jump false, busting false, whichever. Like, if I want to do remote, yeah, can I just use default SSH, or I need to pass all these arguments to the InSpec?
If you have configured SSH already, and so it's using the SSH config. Currently, it's not, so you have to pass it to InSpec, but this is a really good thing that we're currently thinking of about how we can leverage that.
And then the next question, can I pass all these arguments, all SSH options?
Yeah. So currently, I'm not aware that somebody was not able to connect to an SSH remote host. So if you figure out something is not working as expected, please open an issue in InSpec. But SSH is working reliably now for over a year. So we have customers who use it with like alternative sudo commands, for example. They use it with pseudo password. So a lot of commands that you can pass via SSH are available for InSpec as well.
Okay.
Well, thanks a lot, and let's grab a beer.
Thank you.